Today we will consider the mechanisms of the formation of electrolyte solution. In an electrolyte solution, ions interact with solvent dipoles. So, what is a dipole? Let's consider this with water. The water molecule consists of 2 hydrogen atoms and 1 oxygen atom. 3 atoms in a water molecule form isosceles triangle with 2 protons of a hydrogen at the base and oxygen at the top. Thus, in water are well marked 2 poles, negative on the oxygen side and positive on the hydrogen side. A particle having 2 poles is called a dipole. Substances may contain ions in the initial state until dissolved. Such substances are called ionophores. A typical representative of ionophores is sodium chloride, which in the initial state is a crystal built of ions. When it is dissolved in water, the crystal is destroyed due to the interaction of ions with solvent dipoles. To prove this, it is necessary to compare the energy of the destruction of the crystal lattice and the energy of the interaction of ions with the solvent, the so-called solvation energy. If these energies are of the same order, then the ionic system will be stable. The second option for the formation of ions in solution is when ions are formed only upon dissolution. Such substances which form ions upon dissolution are called ionogenic. As an example, consider the formation of hydrochloric acid upon dissolution of gaseous hydrogen chloride in water. In this case, ions are formed due to the chemical interaction of hydrogen chloride with the water molecules to form a hydroxonium ion. The resulting ions enter into an ion-dipole interaction with excess water molecules. Thus, during the formation of a hydrochloric acid solution, the energy required for breaking the hydrogen chloride chemical bond is 432 kJ per mole, which is compensated by the binding energy of the proton with the water molecule in the hydroxonium ion and the hydration energy of the H3O+ and Cl- ions. These are the 2 main mechanisms for the formation of electrolyte solutions.